Good day to you. I'm going to try something quite risky, a machining technique. It may fail. You'll only find out by watching. I'll explain. A few months ago I made a replacement table nut, this is the old one, for my Harrison Mill X-axis lead screw. And I cut the thread in there, which is 3/4 by 5mm pitch, using this boring bar, which is 3/8 diameter, and I ground up a piece of 3/16 high-speed steel. And I could do that on the lathe. Although this bar is pretty thin, I could do it on the lathe. There was enough clearance in there to give me freedom of movement. And I did this with 2 thou cuts in the end, because of the flex on the bar, but I got away with it and it worked. And more recently I made a replacement bronze nut for the saddle lead screw on that Herbert Junior surface grinder. Now the problem with this is it's only a 5/8, 5 TPI, and I couldn't do it on the lathe because I couldn't get that boring bar in there with any clearance. Oops. So I made a tap, and you might have seen that. Now this tap took a lot of work, but somebody said, hang on, you could have saved a lot of time if you had made a line boring thread cutting tool. And what we mean is a tool with a cutter that runs right through like this, and you could put one end in the lathe chuck and the other end in the tailstock, and if you could mount a cutter on this and rotate this but hold the nut still, you would be able to cut that thread in the nut with a thin bar. Because you're holding it at both ends, it wouldn't flex. The question is, could you do it with such a thin bar? Now this is 9mm silver steel, so it can be hardened and tempered, because one of the comments was, if you make one, it has to be hardened and tempered, otherwise the cutting edge will just pull out of the bar, if it's mild steel, for example. So if we look at the line boring threading bar in cross section, circle, yes, I'm sure it would be possible to make a pocket to take this cutting edge here, and then you could have a lock screw at the top and possibly a screw at the back. So you would put your cut on, run it through the work, you'd have to slacken this, back this off, move the insert in, that's what I mean by insert, reverse the lathe, take it to the start of the work. Obviously you'd have to back it off because of the backlash in the gears. If you tried to run it through at the same cut depth, it would just wipe the threads off. So you'd have to go through this cycle, set, cut, do, cut, back it off, reverse out, and so on. Now that sounds like a lot of work, doesn't it? But actually, compared to the amount of work to make this thing, you know, which was days and days, it might be worth it and save work overall. Now, what the commenters said was they use slip gauges to measure this thread depth here. I'm not quite sure how they did it, from behind or here. Anyway, the thing is, can I do it on something as small as this and this? Well, I'm going to try, but as I say, it might fail. So I'm going to use this piece of brass, because you couldn't cut into steel, I'm sure, because the clearances between the bar and the internal diameter here are going to be so small that it would just clog with swarf if you're using something that produced curly swarf. But I think with brass and bronze it would be okay. And I'm going to put this into a bar holder. I don't know if I can get this on shot. Let's try. Here we go. Yeah, I'm going to put it into that. So I'm going to make the whole thing easy for myself. So that's a 20mm bar holder. I'll reduce one end of this to 20, pop it into this. That'll help me get it on height and centered, because obviously this bar has to run absolutely in the center of that. I don't know if there's any room for that screw, quite possibly not. And thinking about it, these would probably have to be, I would use metric grub screws, so it would be 3mm. So they're tiny. And then when I've made this pocket and cut the thread, when I harden and temper this, is it going to, you know, distort? Don't know, don't know, don't know, but it's worth a try. So looking at the figures, as I've drawn this out, this is this bar, 9mm, 9. These two vertical lines either side are the hole in this, 11.5. This is my cutter, and I'm saying the cutter could be 11mm long. So inside of this 11.5, 1/4mm either side. Now when I cut my thread, if I was cutting 5 TPI, the thread depth would be 0.1 of an inch. So that distance there is 0.1 of an inch, but I'm actually saying 2.6mm because when I cut it, my lathe is metric, so I'd reckon about 2.6mm depth. So add to that distance, that's the distance between the 9mm bar edge and the 11.5 hole, is 1.25 either side. So you add it to this, that's 3.85. So this cutter needs to come out 3.85. If it's 11 long, that's 7.15 left, and giving you 1.85mm there. Now this dotted line is the center line where we'd put the screw. This screw, oh you can't see it, it's off shot. The screw that's going to go there to hold it in place. And even with this fully extended to the depth of the cut, this center line is not near the edge of this. Now let's move up so we can see the other drawing. So this is the drawing we looked at first. Now you can see there's no room for that screw from the diagram we just looked at. And also this, if this is going to be 3mm diameter, well, it seems the ones I've got, the grub screws I've got, are 3mm long, deep, whatever word. And there's one on the end of the Allen key, and they're very small. Now, if this is 4.7, which is 3/16, in a 9mm bar, gives me 2.15 either side. If this is 3mm tall, this grub screw, then to not have this sticking out of the top, or to say it another way, to get full use of the thread, I would take 0.85mm ground off the top of that tool bit. Well, I haven't got my surface grinder set up yet, so it'll just be, you know, something manual, but just a little bit of a flat made on the top of that. Now, will that grub screw be sufficient to secure this cutting bit without it being pushed back in? I don't know. This is what, you know, trying this out for real is one of those, you know, what we're trying to do. At the moment, this cutting tip is 13.3 long. And to be honest, I don't really want to grind the back off it to make it 11 long. So at this point, the plan changes, and I'm going to use another cutting bit that I've got there. Now that, which is not behaving itself, I ground that for 8 TPI square thread for making a new nut for the Abwood vise, and that's about the right length. These seem to have become magnetic, I don't know why. Anyway, so you can see it's ground for square cut thread, and it's 10.5 long. Behave yourself. This is a test nut that I made for the Abwood screw, 5/8 8 TPI square thread brass, using that cutter. Do you remember that I broke my video camera and I didn't think I was going to be able to fix it, so I bought another? Anyway, I did, and I put out a video, so now I have 2 cameras. Excuse, there might be some strobing on this. It's just from the phone, and the strip lights here make it strobe. Anyway, you see the 2 cameras, that's the point. Now, it turns out that these 2 cameras, Sony cameras, you can link them by Wi-Fi, so you can control both cameras from one. And I'll show you how that works. So you can see the camera on the windowsill there, pointing down towards the lathe. And on this one, the 2 are linked. Let's get that strip light off there. That's it. The 2 are linked, and I can look at this camera or I can look at the camera which is on the windowsill, and then if I move the zoom on this camera, see if I can do this, it zooms the one on the windowsill, which is quite amazing. And then if I flip it over, instead it zooms this one. So if I press record, I think what will happen is both will start. Let's find the button. Right, yeah, can you see they're both recording? Now I don't normally bother with two camera, it's just a pain to set up. I don't think we gain a lot from it. Yeah, so we can see what that's recording, see what that's recording, and then we can turn this off if I find the button. Where's the button? There it is. So now both have stopped. Clever stuff, isn't it? When I go to dual camera mode, I can't see what my audio levels are, so it could be that this isn't even recording. I wouldn't know. Recording audio is what I mean. Right, that's down to 20, I've just measured it. So next, drill. Just taking this out to 11mm to start with. I haven't got an 11.5mm drill, so I'll have to bore it half a mil. So there's our test piece mounted up. This will be our line boring bar. I'll get this set up on the tool post and take some measurements and decide how long we want this and where the cutter's got to go. Now if we use this cutting tip to cut 8 TPI in this, it's not going to be representative of a real thread, because if this was 5/8 8 TPI, the centre hole would be 1/2 inch, and this is 11.5. But that's not the point. I mean, I know that I can cut this thread 8 TPI 5/8 through a 1/2 inch hole because I did it for that Abwood vice nut, didn't I? The point here is to prove that we would be able to cut a thread through a much smaller hole using this technique. So I've just set this up roughly to take some measurements. So you can see we've got the live center in, so the right hand end of the bar is there, and obviously that's the left. And then if we had the tool here, the cutting edge here, as the carriage moves to the left, it would start to cut into the work, and then measuring the length of the work would take us to about there. So you can see that we need a pretty long bar to make this work, and this is only a short piece of work. But the advantage of this method is there's no theoretical limit to the length of the work. You could cut a really long thread, assuming, you know, that the bar was stiff enough, obviously. Although my Harrison mill doesn't have a quill, I can still drill vertically using the vertical feed by hand. So it's 2mm per turn, so 80 thou per turn. And if I'm careful, that's fine. If I'm using a centre drill, I can spot the work. Anyway, just a bit more about this vise. So I reviewed it, you know, Vivo, about £80. And a lot of people said to me, why don't you just buy a Kurt? Well, I'd love to buy a Kurt. I looked at one the other day on eBay and it was £650. And if you want that in US dollars, add about 27%. So 10 times the price of this. Yes, I think it probably is 10 times the quality, if I'm honest with you. The screw here had bearings at each end. There were cutaways here so you could get the clamping studs much closer together on the table. Oh, and loads of other things. You know, it was like a Rolls Royce versus something else of less quality. I can't think of an example. So 100% totally agree. You know, but it's 10 times the price, and hobbyists can't really afford $850 for a vise normally, and we don't pick up many second hand. I've seen them with holes drilled all over the place for about £450. It's you know, it's just how it is. Reaming it out 3/16. Thank you, Stuart, who gave me these reamers. This is a bit of 3/16 tool steel ground. Perfect, look. Now drilled and tapped. 3mm by 0.5 pitch. Now the last time I did this, I was making the tap for the 5/8 5 TPI Acme thread, and I had a lot of difficulty getting the tap the right temperature all the way along its length because it's basically long and thin. So for this rod, I'm going to take up a suggestion made by a comment, and I've put it in a tube, and I'll put the flame at one end, and hopefully with it sticking out of the other end I should see when it gets to cherry red or hotter. I've got my gloves on just in case of an instinctive reaction. I know not to touch red hot things, but if you're not thinking, better to have the gloves on. Oh, that didn't work. Hang on. There seems to be some technique to this. I'm not sure this is going to work. I'll come back to you in a minute. I was being too cautious. You've got to get the flame running down through the tube. Got it. That's it. Well, we'll try again a more conventional way. Well, I could only get it cherry red around the screw, you know, where the tool's going to go here. Because of its length and being outdoors and a bit of wind, there was no chance of getting beyond about here. But this is the area that we need to be hard anyway, so it doesn't pull the tool out. We'll try and get this to blue then and drop it in. Looks like blue to me. But it has distorted slightly. With a clock on it, we can see. So at the chuck, there's virtually no run out, which is kind of what you'd expect. But once we move up to the cutting bit, 0.2 millimeter. But there's very little flex in this bar. I don't know if it would cut a heavy thread like that, you know, 5 TPI Acme, but for lighter threads it might work. Anyway, we'll press on. Obviously that cutting bit is sticking out far too far. I just put it in because it looks nice. And that's with the other cutter in it, which of course is shorter. I've just run through with no cut just to check clearances, and I've hit a problem. Look, how will I get that tool out of there on each cut? I think we may have to run it all the way to here. So we need this cutting tool to emerge here so I can get to it, to remove it, to reverse the lathe. So looking at this bar needs to stick out at least that much longer. Now it will make this bar really quite long, and I wondered if we'd lose the advantage of being held at both ends. But the point is, I'd be able to cut a nut that long or even longer, which you wouldn't be able to do really with a normal tool coming in from one end with all the flex that it might have on it. So there could still be reasons to use this technique, you know, despite its complexity. Well, it's about 8 in the evening, but as I was tidying up about 5, I knocked one of those little cutting bits off the workmate. It dropped on the floor and it vanished. And I've spent, I don't know, 45 minutes looking for it, and I've found it. I thought this project was going to have to take a different turn and probably go back to plan A using the 5 TPI bit. But can you see it? Under the on the base of the Rapido, but under the motor stand. There it is. That took a while. Where are you? That's it. Come on. There. I need to grind a flat on the top of this tool, and I tried to do it by hand and I could not. So I've made this little jig from an engineer's clamp. Just push that up to the stone, and I'm hoping I can get it the right shape. So this bit of hardboard here is simply to keep this, to give it something for this cutting tool to rest on and keep it at 90 degrees. It's okay actually if there's a little bit of a slope towards the back, because that will help stop the tool being pushed through the bar as it's cutting. Well, that's had the effect that I was looking for, but it's also sharpened that edge of the tool as well. There's a bit of a slope up towards the front, but I think it's okay. And this flat, as it is, will hold the cutting edge vertical, because the flat is about 90 to the blade. All done by eye, but I think it's okay. We're set up for 8 TPI, 50, 63, 40, 120. These two to the left, this one to the right, this one in the end position most right. Because this is a metric lathe, the metric pitches are on this panel anyway here. You just have to turn it over. This is fine side and the other side is coarse side. But for Imperial, I made this chart. Sorry, there's a bit of light glare on it. I mean, sometimes you get these charts inside of here, I've seen them, as a sticker. The chuck is going to rotate the normal way, but that means the tool has to be inverted. Next we need to do all the setup checks. Well, that needs adjustment, doesn't it? I'll tell you what, this camera is better than my eyes. I'll adjust out the error on the tool post. Setting up the bar in the centre with a micrometer, measured this 25, this is 9, half of this is 4.5, half of this is 12.5 millimeters, one from the other is 8. So I should be measuring all the way around 8 between there and the bar. So that's how I would centre it. So the cutting tip is clear at the front, and now it's clear at the back. In case you're wondering, I'm only going to go as far as proving this technique. I don't know exactly what cut I've got on this, we're just going to do it. Half nut is already engaged. I'm nervous. Oh my goodness. Oh dear. Now I'm going to have to run it all the way until the cutting edge emerges here. I've taken the cutter out and I'm running it back. This is tedious. I've put the cutter back in and I think I've added about a 1/4 thou cut. It's very difficult to tell. We'll run this through just the once and then I'll strip it down and we'll have a look at the cut in the nut, and then we'll know if this is a feasible approach. Too much cut, too much cut, too much cut. Oh my goodness. Look at the bar bending. Oh, that was terrible, wasn't it? I'd obviously put on far more cut than I realised. But you know, we are going to finish at that. Not the video, just this operation, and let's have a look what it's done. You'd have to have some way of controlling that cut much better than I can, just trying to guess it with a pair of calipers. Well, I'm quite pleased with that. I think we've proved that this technique would work, but you'd have to have a far better way of setting the cut depth. I can tell straight away by how much that is lower than this that my second cut was far too big, and I've chipped the end of the tool. It has quite a steep rake here, but you need that because you're working in a small hole. But looking at the nut with only 2 cuts, and yes, we got a lot of deflection on the bar because it was such a big cut, but it doesn't look bad, does it? I think, you know, with improvement the technique could work. Anyway, thanks for the suggestion. And to be honest, I've done this quicker than making the tap, but I might have had a lot of difficulty bringing this to success. And this is only a 1/16 wide. Well, imagine what it would be like on a 5 TPI Acme. There would be a lot of strain on this bar. So I'm not saying it was a bad idea, don't get me wrong. Yeah, I've learnt a bit, as usual. Well, for those of you who are still here, thanks for watching. A couple of weeks ago I did a review on a thermal camera. Some people liked it, some people didn't. It's always a bit like that with reviews. Anyway, I had a question. Would it be useful for spotting intruders in your garden at night, hiding behind the bushes, including meth heads, as he put it? So I tried it outside the other night. I didn't spot any meth heads, but you'll just have to judge for yourself whether you think it was, you know, whether it worked or not. Anyway, thanks for watching, and next time, back to the surface grinder. Well, I'm just taking a piece of video now, and I think you'll agree that looks pretty black. And I'm going to take another video, but using the thermal imaging camera. Because I better not say too much because you get bored with this because there's nothing to see, is there? But you will in a minute. So this is the same scene that I've just videoed that looked pretty much all black. And here you can see heat from the trees and heat from that wall over there. Did you see the video of me putting the fence up? And this is showing exactly the same scene. But I bet you can't see the fence, can you? You can certainly walk around with that thermal imaging camera and, you know, without any other light and guide your way. It looks like there's something in this tree. I can't see it with my eyes, but I'm sure it's there, you know. Come on, little birdie. Well, it's not a pigeon, is it? But it is a bird roosting in this little tree. I can't zoom with this. It's as still as anything, but I'm sure it's there.